change from 20% 50% sudden change in use of composite. That means the composite have come and they are proved and they are the material of the century. They are used for getting many advantages which I am not listing here. But as you can see, this is the aeroplane which is flying. This one structure made out of composite taken from the company. You can see the entire fuselage in that the skins and the stiffness bonded together and the frames bolted later. So this is slightly old side. The trend in composites today, I put up 2010 because of some time back. The trend is continuing. The composites is enjoying and it's taking the metallic area. You can see how much it has increased over the period. This is an interesting slide which I would like to put. Here the composites, you can see in the beginning, somewhere in 2000 and all, it was something around 20%, we can see. Now there is an increase. You take any aircraft in the world, the latest aircraft, either it may be fighter or a transport or a cargo, the increase is over 50%. In the production, in the commercial aircraft. So even LCA is around 48%, you can see 7. Recently you might have seen that Airbus 350, it's on 14 has flown, wide body, it's over 50% composite. That is the composite has given confidence, yes, can perform. But at the same time, it has the disadvantage also, like the cost. The cost is one important factor, the raw material cost and the conversion cost. So the one good thing is the cost of the composite, particularly fiber, carbon fiber, coming down as it uses increasing, and new technologies like resin transfer molding, the infusion molding, they are coming into production, thereby the cost is coming down. So then repairs schemes have been developed and been certified. So with all these things, now we can say the composites, yes, they are in the aerospace area. I'll talk about other aerospace. In non-aerospace areas like sports, automobile industries, marine, offshore, coal sectors, the composites are finding they are making their way and they are giving distant advantages using them. Just one or two, if I talk about it, the marine, the demand for faster, increased payload, they have shown interest in composite materials. Increased speed from 18 to 25 knots is possible in this, which is not possible in original metallic structures. Okay. One more thing is about this magnetic signature. They are not visible. So there is one very good point, and shock and corrosion resistance, major thing in bearing. So these are corrosion resistant and fire performance, good fire performance, reduced weight. Though originally they are costlier, but if you take it over lifetime, over number of years, yes, the cost comes down. That's what people look at it nowadays. So in that way they are more durable, they are cost effective. The applications in marine, they include superstructures, masts, hulls, secondary, secondary hull structure like decks and bulkheads. Now it has been established that composites are the material, are a construction material for marine application also. If you look at this automotive, the main person in automotive is maximum cost of structure goes by the materials and processing. So now because the materials have become slightly cheaper, because they have been used and new processes are coming up, they are finding it to use better and advantageous to use them. The typical applications are engine powertrain, basically manifolds, pump buds, which are the corrosion, and impellers. And in chassis, particularly springs and the control arms, subframes, and the in the bumpers and body panel. So, but use is, there's no sudden jump like in aerospace application, but it's increasing but steadily increasing. Because the cost, the cycle time and the quality and fit and finish and the painting problems are slowly sorted out and they are overcome with this now, because production rates, the important rates have become very high, and you can produce parts in few seconds nowadays. Earlier it would take particularly hours to make. Now the technologies and materials have come where you can produce parts in seconds. That's major thing. In oil and gas industry also, where the corrosion is a main problem, and in installations, the metal products, they require intensive maintenance. Probably in 1 or 2 years itself they will go off. You have to maintain them and then replace them many times. Whereas FRP, they last much longer and require minimum maintenance. And so now they have been there for over 20 years. It's one more area of the problem. For a continuation, we can find where particularly staircases and then stair thread covers, communication radars, and they are very quick and easy to install. That is a major advantage, and no welding required, and they can be assembled very fast and they can be removed very fast. And they don't need very heavy cranes even to load them. These are the advantages of the composite. What I want to conclude here is, in aerospace application, the polymetric composites, the use is well established through fighter aircraft and naval aircraft, helicopters, spacecrafts inside, IRS, in the rockets, missile programs, and civil aircraft like Saras and new aircrafts also coming now. And in non-aerospace, they are highly promising. But you can see that where are the manpower? Where do we have people who is working in composites? You can find people mostly in postgraduates working or offering, the universities offering some composite courses. But in graduate level, where are the people? Where do you get people to work in composites? A large vista is available to you, but we don't have people. Either in a mechanic level or engineer level. How many engineers are ready to work in composite? How many engineers know about composites? But so much field is there. So this is one area we feel that yes, they should be a regular curriculum to have people, to have engineers having background, having experience in composites. See, that's what I want to put in that. Now, the lot of MNCs have gotten a lot of 350 jobs, Airbus. They are working on composites, but they don't have people to know how the composites are made, how composites are joined, how to assemble them. It has become very difficult for them. And now people are taking the people, training them for years, months, and they are giving them different programs, and it's become very expensive. They don't get people. So my only suggestion is either universities or college level, why can't you introduce a course on composites? And I can they will introduce a course in composites, particularly hands-on experience. Why not they have a laboratory in composites? They have a laboratory in hydraulics, laboratory in testing. Why not? Why not have a composite lab and have a course? So this is my sincere thing. Even small scale industries to work as type 2 companies support them. There are so many people I am coming, they are asking me, can you give lecture, can you come and help them out? It's very difficult. Okay. So, what I feel is they need to set up laboratories and train the people in small areas, make some composite parts, show the machine operation, hands-on experience and instruction and repairing technology. Now the composites are there in the aircraft, in other areas, but how do you repair them? You have and repair technique, repair method, practical repair of that. So, doing these things, we need people in this area. Thank you.
Sir, one doubt.
Yes, sir.
Heat transfer. Thermal properties.
And the thermal operating temperature.
Operating temperature.
Yes, sir. I talked about polymetric composites. We can grade them as one composite maximum service temperature is 300 degrees centigrade. 300 maximum. But that area is very small. So generally the composites using the modified epoxy resins can work to 150 degrees centigrade continuous use. Maybe short time period can go up to 170, but continuous is 150. That is modified epoxies. They come to that. So if you want slightly higher, you have to go for bisphenoamides. Maybe 180, 200 maximum. If you need still further for some complications, you can go in for polyimides around 250 to 300, but they are very, very expensive. They are very expensive. Nowadays, as you can see, the aircraft interiors, they are making phenolics. Now they go higher testers because they have got very high temperature range, around 300 plus low toxicity, gas emission, what you call the properties. Because in an aircraft inside this, it catches fire, people should at least be able to breathe in. Oxygen should be there. This should not burn. Okay, so these are the properties specially available for composites, not in metals.
Regarding strength.
Strength?
Yeah.
So if you strength, what we talk about, I didn't talk about it, they are available everywhere. We talk about the performance, that is specific strength and specific stiffness. Specific strength E by rho, sigma by rho. So that is highest is our aramid composites. Highest in the world available is, if you divide the ultimate strength by density, the highest is aramid composites, followed by carbon, glass, metal composites. If you take stiffness, yes, carbon are stiffer, but steel is stiffer definitely. But if you took A by rho, this gives advantage. Okay, but in structures you take E by rho, not only E by rho, you take square root of E by rho, cube root of E by rho. In bending, in buckling, you should consider them and make a list of performance index.
Okay.
And
one more thing, good thing you told regarding the lab of the composite material.
Yes.
My son is studying MTech in evolution of technology, so I can suggest to the college to have a lab for the composite material, because even one subject is there for MTech.
That's fine, sir. You can see MTech one subject will be there. Whereas the opportunity is so many things there, but we don't.
I will request the Vice Chancellor to open a composite lab there.
Thank you, sir.
So that it will be helpful to everybody. Thank you for your.
In fact, in some of the colleges, autonomous colleges, what we call,
yes, sir. But that
has been introduced as a elective, and in fact I call it as a compulsory elective, and I offer it regularly. And as far as the lab work is concerned, naturally the limitations are there. I think the industries which are engaged in this, or maybe organizations like NAM, etc., should help the students at MTech level at least to take up the project.
So instead of requesting NAL who are busy in their own work.
No, I am just telling. I mean, organizations, if they come forward to tie up with institutions.
Why tie up, sir? Why not the college themselves have a small laboratory?
We have been doing.
I am not talking about very expensive.
Right.
Simple bagging vacuum bagging techniques.
Right.
Curing.
Now even hand layup we have done some laminates.
Produce quality products.
Right.
Thereby you can also take up some research work.
Correct.
And also help the industries and give some products.
In fact, recently I have added one of the projects in epoxy based glass fiber reinforced composites. Yes. We have come out with very good results.
Yes.
The only thing is that has to be, as you said, evaluated in detail for some more properties, and maybe later on it can be used as a product also.
Yes.
Thank you.
It's a core, not electives.
But
as you said, we don't have any composite lab as it is.
Yes,
but I am developing a composite corner, but so that some 2 or 3 UG people can make projects. Right? Almost 3 or 4 projects every year. The final UG people do in composite.
See what happens, sir? If that is they become more employable. For example, if man says, I have worked on composite, I know about composite. Definitely, there are so many projects going on. For example, recently I saw PMO has cleared about 2,000 crores for RTA, regional transport aircraft. If you look at it will be definitely much more composite. There are people are needed there in design, manufacturing, tooling. Tooling is one very important. None of them. In fact, we are suffering in our country because we can't productionize. We don't have people in that area. So we make initially, but we have to productionize, make the cost come down. That's my sincere request to all the academic people. Yes, please look at it.
Okay, sir.
So if you are making
EDA as a project director in charge for productionizing the LCA structure, so which has got over 45% composites. There you can see the wings, fin, all of them are composites. They have to be assembled, they have to be machined, holes have to be determined in metal. All these problems are to the extent solved to some extent, but yes, there are still some problems which have to be done. Basically, I am taking the production rate of increase, the cost of the thing, all of them have to come down. And we need people to work in it. The whole thing is that we take general mechanics and then import them training. Yes, then he makes lot of mistakes. In fact, we have thrown many parts worth lakhs together because of smallest mistake. So those areas we can't afford. So that's why my only request, yes, these things are all, if they are imported, a hands-on experience. Yes, a man who comes up to me, he doesn't know what is a fiber, doesn't know in glass, he has not seen. He has not seen a composite. So these things are done, they will be directly employable to many organizations. As you see, last 14 Airbus 350 wide body, just flown 4 hours. It has over 50% composites. It was reached 20% much earlier, about 10 years back. Suddenly they jump in. So that's it.
Sir, myself, I am Abdul Latif from Nizam Institute of Engineering and Technology, Hyderabad. Sir, we have established a composite lab apart from the curriculum, and we have fabricated many components using composite.
Yes.
For example, our leaf springs, bumpers, doors.
As that autoclave, in order to cure composites of space grade, particularly where you have to have very low void content, and there it needs lot of consumables which are very expensive. They are all imported, but however, because of the effort made by few people, few organizations, over 80% they are indigenous now. They are available over telephone. Because most of them have got shelf life. For example, vacuum bag sealants, each need to them, they have got a shelf life. By the time you get them abroad and get it here, the life would have been limited. Maybe you have few 20% life left over. But keeping this, Dr. Kotari took a lead and set up a lab, set up a group of people to engineer this system. So with that now it's available in our country. Over telephone you can order them and get them, whatever quantity you want. So the plus point is, I said autoclaves available, it's a cheap rate, and consumers are available.